Paper is something we use every day. Books, notebooks, packaging, newspapers, yet most of us never stop to think about how it is actually made. Behind every simple sheet is a carefully controlled industrial process that combines biology, chemistry, and mechanical engineering. Let's walk through the complete journey of paper, from raw material to finished product, in a clear and accurate way. The process begins with raw materials. Most paper is made from wood, taken from trees grown specifically for papermaking. These trees usually include softwoods such as pine and spruce, and hardwoods such as eucalyptus and birch. Softwoods have long cellulose fibers that give paper strength, while hardwoods have shorter fibers that improve smoothness and print quality. In addition to wood, paper can also be made from cotton, hemp, bamboo, and recovered waste paper, depending on the type of paper being produced. Once trees arrive at the paper mill, the logs are first debarked. The bark is removed mechanically and is often burned as a biofuel to generate energy for the mill. The debarked logs are then cut into small uniform pieces called wood chips. These chips are carefully sized so they react evenly during the next stage of processing. The next major step is pulping, which is the process of separating wood into individual fibers. There are three main pulping methods used in the industry: mechanical pulping, chemical pulping, and recycled pulping. In mechanical pulping, wood chips are physically ground or refined to separate the fibers. This method keeps most of the wood intact, including lignin, the natural substance that binds fibers together in trees. Because of this, mechanical pulp has a high yield but produces paper that is weaker and yellows over time. This type of pulp is commonly used for newspapers and low-cost paper products. Chemical pulping removes lignin using heat and chemicals, leaving behind mostly pure cellulose fibers. The most widely used chemical method is the Kraft process. In this process, wood chips are cooked in large pressure vessels called digesters, using a solution of sodium hydroxide and sodium sulfide. These chemicals dissolve the lignin while preserving fiber strength. Chemical pulps are stronger, more durable, and are used for printing paper, packaging, and high-quality products. Recycled pulping uses recovered paper as the raw material. Waste paper is mixed with water and mechanically agitated to separate fibers. Inks, adhesives, and contaminants are then removed through washing, screening, and flotation processes. Recycled pulp helps reduce the need for fresh wood, though fiber quality decreases each time paper is recycled. After pulping, the pulp is washed to remove dissolved chemicals and unwanted residues. It then passes through screens and cleaners that remove remaining impurities such as bark fragments, sand, or plastic. Many paper grades also undergo bleaching at this stage to increase brightness and whiteness. Modern bleaching processes are designed to minimize environmental impact and often avoid elemental chlorine, using safer alternatives instead. Next comes stock preparation, where the pulp is refined and blended. Refining slightly roughens the fiber surfaces so they bond better with each other, increasing paper strength. Different pulps may be mixed together to achieve the desired balance of strength, smoothness, and cost. Additives are also introduced at this stage. Fillers like calcium carbonate or clay improve brightness and opacity. Sizing agents control how paper absorbs liquids, which is essential for writing and printing. Other additives may enhance color, durability, or resistance to moisture. The pulp mixture is then heavily diluted with water, often more than 99% water, and sent to the paper machine. This marks the beginning of sheet formation. The watery slurry flows onto a moving mesh belt known as a forming fabric. As the mixture moves forward, water drains through the mesh using gravity, suction, and vibration. The fibers gradually interlock and form a continuous wet sheet. Even at this point, the sheet still contains a very high percentage of water. After forming, the wet sheet enters the press section. Here, it passes between large rollers that squeeze out additional water. Pressing not only removes moisture efficiently, but also compacts the fibers, improving paper strength and surface quality. Removing water mechanically at this stage saves a significant amount of energy later during drying. The sheet then moves into the drying section, where it travels over a series of steam-heated cylinders. These dryers evaporate the remaining water until the paper reaches its final moisture level, usually between 2 and 6%, depending on the paper grade. Drying is one of the most energy-intensive parts of papermaking, so modern mills use heat recovery systems to improve efficiency. Once dry, the paper goes through finishing operations. Calendaring smooths the paper by passing it between polished rollers, adjusting thickness and surface texture. Some papers receive a coating made of pigments and binders to improve appearance, gloss, and print quality. The finished paper is then wound into large rolls and cut into sheets or smaller reels based on customer requirements. Recycling and environmental control play a major role throughout modern papermaking. Many mills operate closed-loop systems that recover chemicals from the pulping process and reuse water multiple times. Wastewater is treated before being released, and recycled fiber is blended with virgin pulp whenever possible. While paper fibers cannot be recycled indefinitely, recycling significantly reduces resource use and environmental impact. In the end, papermaking is a precise balance of natural materials, chemistry, and engineering. What begins as wood or recovered paper is transformed through controlled steps into the sheets we use every day, quietly supporting education, communication, and industry across the world.